Hello students. Today we will discuss the last article in the chapter higher order differentiation or higher order derivative. Now y is equal to f of x is differentiable function on interval I. That means y is equal to f of x is a differentiable. We can find its derivative. We write dy by dx and derivative of f of x is right in another form f dash of x. That means we take first time derivative, one times derivative. Dy by dx is equal to f dash of x. But this f dash of x or again derivative of this function is a differentiable on I. Then again take its differentiation. Differentiate with respect to x, that is d dx of dy by dx is equal to second order derivative, that is second time derivative. We write f double dash of x. Left hand side is right d2y by dx square. Now in this way we take one example. For example, y is equal to sin x. Now sin x is a trigonometric function which is a differentiable. Differentiate with respect to x, then its derivative is dy by dx is equal to derivative of sin x is cos x. Again this cos x is a differentiable which is a trigonometric function in its domain which is also differentiable. Differentiate with respect to x d dx of dy by dx is equal to minus sin x. That means we take 2 times differentiation of sin x, then we get minus sin x. That means we write second order derivative d2y by dx square is equal to minus sin x. This dy by dx is the first order derivative. Here one we cannot write, but first order derivative cos x, second order derivative minus sin x. Again this is also differentiable. Differentiate with respect to x, then d3y by dx cube is equal to minus derivative of sin x is cos x, which is called as the third order derivative. First order derivative, second order derivative, third order derivative. Continuing this process, if n times differentiable function, then nth order derivative of given function nth order is dny divided by dx raised to n is equal to, we can find again general form, but we are study only the how many find the nth order derivative or the higher order derivative. Now the notation of higher order derivatives are y1 first order derivative, y2 second order derivative, y3 third order derivative, that is yn nth order derivative, or f dash of x first order derivative, f double dash of x second order derivative, f of 3 of x. We cannot write always the double dash triple dash is complication, therefore f bracket 3 f raised to bracket 3 of x means third order derivative. Continuing this process, f bracket n x, it is nth order derivative, and generally we write dy by dx d2y by dx square d3y by dx cube Continuing this process, dny by dx raised to n, which is called as the nth order derivative. We find nth order derivative in this way, but in our text or our syllabus only the find second order derivative, that is to find dy by dx of the given functions. By taking some important example in our text, solve how to find the higher order or second order derivative. Our first example is find second order derivative of y is equal to e raised to 4x into cos x. It is given y is equal to e raised to 4x into cos 5x. Now, which is the product of two function u into v. That means we apply the rule of derivative, that is product of two function, differentiate with respect to x dy by dx is equal to first function e raised to 4x, then take derivative of second, that is phi d dx of cos 5x, plus second function is same cos 5x into take the derivative of first function u e raised to 4x. We apply the rule to find the derivative by using the u into phi is equal to e raised to 4x. Derivative of cos function is minus sine 5x. But in place of x here 5x, that is function of function. Again take derivative of 5x is only 5 plus cos 5x into derivative of e raised to x is the e raised to x, e raised to 4x, because in place of x here 4x. Again take derivative of 4x is only 4 into derivative of x is 1. From these two we find e raised to 4x common, e raised to 4x bracket 5 into minus 5 into sine of 5x plus 4 into cos of 5x. In each term e raised to 4x is common, therefore we take outside the bracket, and remaining function is the, or both are trigonometric, which is the exponential function, this is the trigonometric function, and we find the first order derivative in this way, which is the final answer. But here ask find second order derivative. That means again product of trigonometric and exponential function which is a differentiable. Then we take differentiate with respect to x. Again we apply u into v, or first into second, first function, second function. Then d2y by second order derivative dx square is equal to first e raised to 4x into d dx of minus 5 sine of 5x plus 4 cos of 5x plus second function minus 5 sine of 5x plus 4 cos of 5x into d dx of first function is e raised to 4x. Now first e raised to 4x is same, e raised to 4x. Again take derivative of sine 5x, minus 5 is constant, derivative of sine 5x is cos 5x but in place of x, 5x function of function, right, derivative of 5x is 5 plus 4 into cos 5x, derivative of cos function is minus sin 5x. Again the coefficient of x is 5, that is its derivative is 5 into x, 5 bracket complete, plus minus 5 sin 5x plus 4 cos 5x into derivative of e raised to x is e raised to x, but e raised to 4x here, therefore its derivative is e raised to 4x, and again derivative of 4x is 4. Now again these two terms, take e raised to 4x common, e raised to 4x bracket, this 5 into 5 minus 25 cos 5x, 4 into this 5 plus, minus 20 sin 5x. Here check third term, minus 5 into this 4, minus 5 into 4 is minus 20 sin of 5x, and this 4 into 4 plus 16 cos 5x bracket complete is equal to e raised to 4x bracket. Now these two terms are same, 16 cos 5x and minus 25 5x, but coefficient is different. Minus 25 plus 16 is minus 9, minus 9 cos of 5x. Now this sin 5x minus 20 and minus 20 minus 40 sin of 5x. Now take minus common, minus e raised to 4x bracket 9 cos 5x plus 40 sin 5x, which is the second order d2y dx square, second order derivative of given functions. In this way we find the second order of the given function. Now take the second example. Now this function, find d2y dx square, x is equal to sin theta, y is equal to sin cube theta at theta is equal to pi by 2. Now this function is a parametric in terms of theta. That means first we find the derivative of given function is parametric form. Again we want to second order derivative at theta is equal to pi by 2. That means in last step substitute theta is equal to pi by 2, then we get the answer. Now first find derivative of x, x is equal to sin theta, differentiate with respect to theta, dx by d theta is equal to cos theta. Again now we write this equation 1. Y is equal to sin cube theta, again differentiate with respect to theta, dy by d theta is equal to 3 sin square theta into derivative of sin theta is cos theta, equation second. Now we know that dy by dx in parametric form is dy by dx is equal to dy by d theta divided by dx by d theta. Then dy by d theta is 3 sin square theta into cos theta divided by, from equation 1, cos theta cancel, is equal to 3 sin square theta. Now we take the first order derivative, dy by dx is equal to 3 sin square theta. Sin square theta is a trigonometric function which is also differentiable. That means we take its differentiation again. Differentiate with respect to x d2y dx square or d dx of dy by dx is equal to d dx of the value of dy by dx is 3 sin square theta. Now here we find derivative with respect to x, but the function in terms of theta we cannot find its derivative in this way. Therefore change the variable in this way, d theta of 3 sin square theta into d theta divided by dx. This d theta and d theta will be cancelled, then we write d dx. That means there is no change, only an adjustment to find derivative of 3 sin square theta in terms of theta, not in terms of x, is equal to derivative of this function is 3 into 2 is 6 sin theta. Again derivative of sin theta is cos theta, and this d theta divided by dx can be write 1 divided by dx by d theta. Equation 1, dx by d theta is cos theta, which is not is equal to 0. Therefore we write in this way, is equal to 6 into sin theta into cos theta into 1 divided by, from equation 1, dx by d theta is cos theta from 1. Cos theta cancel, 6 sin theta. This is the second order derivative of given function is 6 sin theta. And last step, find particular solution d2y by dx square at theta is equal to pi by 2, 6 into sine, in place of theta we substitute pi by 2, is equal to 6 into sine pi by 2 1. Its answer is 6, which is the solution of the given functions. Here write support from 1 and 2, since from 1 and 2 write first order derivative. Now important things in this example is to find the second order derivative. Then here the variable is not in terms of x. In each example we adjust in this way. D, suppose a variable is t, then we write d dt into d dt by dx. In this way we find the second order derivative of parametric function at that point. So which is the most important example. And third example is we have to given some relation, and by using second order derivative show that this y is given. Find first order derivative, second order derivative. There are two methods. First find dy by dx, find d2y by dx square. Substitute these values dy by dx, d2y by dx square in this equation. Right hand side is 0. Then we get verify this equation or verify the answer. There are two methods. First method is given y is equal to log of x plus under root x square plus a square raised to m by using law of logarithm m into log of x plus under root x square plus a square. Again, differentiate with respect to x dy by dx is equal to m into derivative of log function is 1 divided by variable, but here variable is x plus under root x square plus a square, which is the composite function. Then take its again derivative x plus under root x square plus a square is equal to m divided by x plus under root x square plus a square into its derivative is derivative of x is 1 plus derivative of root x 1 by 2 root x. It is 1 by 2 in place of x square plus a square. Again in root x square plus a square is function of function, take its derivative. Derivative of x square is 2x. A square is constant, its derivative is 0 plus 0. We cannot write here plus 0 because the value does not change. Is equal to m divided by bracket x plus under root x square plus a square into in second bracket take LCM 2 under root x square plus a square, here 2 under root x square plus a square plus 2x is equal to first bracket same m divided by x plus under root x square plus a square into take these two common, these two cancel, first write 2 common, 2 bracket root x square plus a square plus x whole divided by 2 under root x square plus a square. 2 to cancel, again this bracket and this bracket is same, cancel these brackets, and only m divided by under root x square plus a square, that is the first order derivative is m divided by under root x square plus a square. But in the answer x square plus a square is not in under root, that means here we take the square, then this root will be cancelled. Taking square on both sides, on both side, then left hand side square is dy by dx bracket square is equal to m square divided by x square plus a square. Now transfer this denominator in left hand side, x square plus a square into dy by dx bracket square is equal to m square. That means in right hand side only the constant term, and left hand side product of two function, first and second. We want to second order derivative, therefore we add this in this way. Now we want to second order derivative, therefore differentiate with respect to x. First function x square plus a square, derivative of second function d dx of second function is dy by dx bracket square plus dy by dx bracket square into d dx of x square plus a square is equal to derivative of right hand side m square. Some students can be write twice m, but m is not variable, m is a constant, its derivative is 0. Therefore, next step, x square plus a square into derivative of x square is twice x. In this way, its derivative is 2 into dy by dx, function of function. Again takes its derivative, dy by dx, g dx of dy by dx plus dy by dx bracket square into derivative of x square is twice x plus a square is constant, its derivative is 0 is equal to 0. Now write next step, x square plus y square into 2 dy by dx into the second order derivative can be written in this way, d2y by dx square plus dy by dx bracket square into 2x is equal to 0. Now these two terms, there are 2 and 2 is constant, as well as here dy by dx bracket square dy by dx is also constant. Therefore twice dy by dx take common on both term. The remaining term is x square plus y x square plus a square into d2y dx square plus x into dy by dx is equal to 0. Now dividing both side by 2 dy by dx. Dividing both side by twice dy by dx. Then this twice dy by dx cancel, right hand side is 0. Then we get x square plus y square into d2y dx square plus x into dy by dx is equal to 0. Now which is the final answer? That is show that x square plus a square plus x square into second order derivative plus x into first order derivative. Now this answer is correct. Yes, in place of a square I write y square, which is not correct. Is x square plus a square first bracket derivative second order derivative plus x into dy by dx, which is the final solution. In this way we solve the higher order or second order derivative in our textbook exercise, and today this first chapter will be completed. The home assignment number 12 I have to give the next lecture. Thank you.